Assalamu alaikum, grade 8. Today we are going to be discussing concepts in gear systems. You may remember some of them from term 1. Okay, so let's look at this first concept. You investigated gears. Counter rotation occurs when two spur gears mesh together and rotate in opposite directions. Okay, so you had a driver gear and a driven gear, and they rotated in different directions. One went anti-clockwise while the other went in a clockwise direction. Different size gears will rotate faster or more slowly depending on the size of the driven gear. Velocity ratio is how fast a gear rotates. Force ratio occurs when a large gear drives a smaller gear. Although the large gear might rotate more slowly, it has a stronger turning force, okay, or torque. Let's move on. Spur gears of unequal size and counter rotation. So these are examples of spur gears, as you can see here. Okay, counter rotation is when the gears spin in opposite directions or rotate in opposite directions. Two mesh spur gears of unequal size will turn in opposite directions. If you look at this figure here, the driver gear rotates clockwise and the driven gear will rotate anti-clockwise. They rotate in a counter-rotational direction. That means an opposite rotational direction. The size of the gear wheel has no influence on the direction of rotation. Spur gears of unequal size and velocity and force ratio. So we can look at two gears of unequal size and velocity and force ratio. Now remember, velocity ratio is how fast the gear rotates, and force ratio is when a large gear drives a small gear. Okay. A force occurs in the system when two spur gears of unequal size are meshed. As the large driver gear rotates slower than the smaller driven gear, the smaller gear is rotated with a greater force. Okay, this means that the mechanical advantage is more than one, and this is how we represent it. If a small gear drives a bigger gear, there is a negative force multiplication. That means that a great force is not produced when there is a small driver gear. This means that mechanical advantage is less than 1, and this is how we represent it. Remember that there is a constant trade-off between speed, velocity, and size, force. Force can be multiplied in a gear system at the expense of speed. So when force is increased, speed is decreased. Okay? Let's look at spur gears of unequal size and velocity ratio. Remember, velocity ratio is how fast the gear rotates. So if we have two gears of unequal size, okay, a number of different things happen when spur gears of unequal size mesh. The larger gear in this figure here will rotate more slowly than the smaller gears. The smaller gear is driven by the larger gear and rotates at a much faster speed. Remember that the smaller gear has much less teeth. Therefore, it will make more revolutions than the bigger gear with more teeth. Therefore, the velocity ratio of the smaller gear is faster than the larger gear. A spur gear with more teeth will rotate slower when it meshes with a gear with fewer teeth. Okay, because it will take longer to make a revolution. Two spur gears connected via an idler. Now remember, when we put a gear in between two spur gears, that is known as an idler gear, and it will allow the driver gear and the driven gear to spin in the same direction. To rotate in the same direction. When an idler gear connects two spur gears, it is called a gear train. The driver gear rotates in a clockwise direction. The meshed idler gear will rotate in an anti-clockwise direction, and the driven gear will rotate in a clockwise direction. So the driver and the driven gear rotate in a clockwise direction. Synchronized rotational direction occurs in a gear train where the driver gear and driven gear rotate in the same direction. An idler gear is usually small and has to turn another gear. Okay, it is made from a harder material than the other gears. The material used to make the idler gear must be high quality of an effective metal that is durable. The material should be easy to maintain and strong enough to withstand. So here is an example of an idler gear in a gear train. Okay, it needs to be very strong. Let's look at bevel gears. Now, remember we did bevel gears. Okay. Bevel gears linked to transfer the axis of rotation to 90 degrees. So if we look at these figures here, notice how the bottom gear is linked to the top gear. Bevel gears can change the axis of rotational movement.